Welcome my dear students. Today we are going to learn the experiment verification of the laws of resistances using the Wheatstone meter bridge. For this we need the circuit diagram. See here. See whatever this setup this is the Wheatstone meter bridge. There are the two L-shaped metal strips and this one straight metal strip. Because of these metal strips, they form the two gaps. One is the left gap, this one, and this one is the right gap. You can see there is a AC long wire, uniform wire, which is 1 meter long, and that's why it is known as the meter bridge. Now again you can see there are the battery, key and the rheostat connected in series across the wire AC. Also from the B terminal, see this is the B terminal on the straight metal strip that is connected to the jockey through the galvanometer, and the same connections we have to do with the apparatus also. See what laws we have to verify. We have to verify the laws of the series combination and the parallel combination. See, series combination means two resistances we have to connect one after the other and their resultant we have to connect here. And in the parallel combination, we have to connect the same two resistances one below the other, so that will form the parallel combination. And we have to verify the laws, that means Xs is equal to x1 plus x2. See, you can see the formula are given here for the laws. For the series combination, Xs is equal to x1 plus x2. And whenever the two resistances are connected in parallel, at that time this formula we will use xp is equal to x1 into x2 divided by x1 plus x2. So these laws actually we have to verify this Wheatstone meter bridge. Now actual setup, actual connections we have to see here. Okay, see the same setup is here. You can see there are the two L-shaped metal strips. This one. Also there is a straight metal strip, and on this straight metal strip there is a B terminal. There is a B terminal. You can see this one is the A terminal and this one is the C terminal. Again see AC terminal, and along that AC terminals there is a 1 meter wire is connected. See, between the two metal strip there form the two gaps as I told in the circuit diagram. So this one is the left gap and this one is the right gap. Now from the A terminal across this AC wire we have connected the battery, key and the rheostat as shown in the circuit diagram. I already told you in the circuit diagram. Okay. Now in the left gap we have to connect the unknown resistance. Initially we will see the series combination. Okay. See this is the series combination. I had done the connections here. That means two resistances we have to connect one after the other. You can see 1-to-1 connection. See, from this gap to this terminal, from the other terminal of the resistance to this terminal, and then this resistance other terminal goes to this one. That means between this gap we have to connect, across this gap we have to connect the two resistances series combination. This is known as the series combination, one after the other. Okay. Now see B terminal. From the B terminal we have to connect to the galvanometer. Okay, and galvanometer's other terminal goes to the jockey. This one is the jockey. This is the pen like instrument that is known as the jockey. And here we have to connect the long wire, because that wire will goes to the A terminal to the C terminal. That's why always remember students, we have to connect the longer wire here. Okay. Now in the right gap we have to connect the resistance box. See, I have already done the connection. See, only you have to connect the wires like this. And one thing you remember students, whenever you are doing the connections, before connections you have to tight all the keys. In this way you have to tight all the keys of the resistance box. It is the variable resistance box, because we can select the any value of the resistance from this resistance box. Okay. So this is the upper connection. This one is the upper connection from the circuit diagram. The middle is the uniform long wire connected across the AC wire. And see the lower connections. From the A terminal that goes to the positive terminal of the battery, negative goes to the key. See here, key. Whenever you are doing the connections, key should be open. ये देखो बच्चों, this key is inserted, that means it is the closed. Okay, and it is not inserted, it is removed, that means it is the open. So you must know what is the open key and the close key. See, this is the closing the key, that means the path is there for the current flow. You open the key like this. Okay, now the other terminal goes to the constant of the rheostat. This is the apparatus, that is the rheostat. Okay, in the rheostat you can see there are the two constant terminals, and this upper one is the variable terminal. There should be no mistake while doing these connections. Okay, remember these are the constant terminals and this is the variable terminal. So one terminal of the key goes to the constant terminal as shown in the circuit diagram, and the other constant terminal is free, and the variable goes to the C terminal. So all these are the connections I already done. Only one thing I told you about the rheostat. See, it is the symbol of the rheostat. Okay, while doing the connections you are mostly doing the mistakes here. Okay, so this rheostat we have connected here in the circuit diagram. So how to do the connections? As I told, in the rheostat there are the two constant terminals and the one is the variable one. So that among those constant terminals, see, this one constant terminal goes to the key and the other constant terminal is free. Okay, that's why this terminal is free and this is connected to the key. And this arrow terminal, that means the variable terminal, you can see in the circuit diagram there is an arrow. That arrow goes to the C terminal. Okay, same way here, see here, same way, this is the symbol and this is the rheostat. These are the two constant terminals. One constant terminal goes to the key, one constant terminal goes to the key, other constant terminal is free, other constant terminal is free, and the variable, the arrow terminal goes to the arrow terminal goes to the C terminal. Okay, see, arrow goes to the C terminal. In this way we had done the connections, and how to take the readings, that I am going to show now in the next video. Thank you. Yes, welcome my dear students in the second video for the experiment verification of the laws of resistances by using the Wheatstone meter bridge. See, in the first video we learned the circuit diagram and also we saw the connections, how the connections had done. Now how to take the readings, that we have to learn. See, in the experiment we have to do the some adjustment first. Take the some value of the resistance from the resistance box. Suppose I have taken the 10 and the 20 ohm resistance. 10 and 20. So 30 ohm resistance I had taken from this resistance box. After that, close the key and switch on the circuit. Close the key and switch on the circuit. Okay. Touch the jockey at the A terminal so that you are getting the deflection in the galvanometer. You can see in the galvanometer there is a 30 divisions deflection on the one side of the zero. Again listen students, suppose if you are not getting that 30 divisions deflection on the other side, you have to take the help of the rheostat. Okay, with the rheostat you can obtain that 30 divisions deflection on the one side. Okay, then touch the jockey at the C terminal so that you are getting the deflection on the other side of the zero in the galvanometer. As you can see, there is a 0 at the center. Then the divisions are 10, 20, 30. So this is the one side of the galvanometer and the other side of the 0, 10, 20, 30. So whenever we touch the jockey at the A terminal, we are getting the deflection on the one side. And whenever we touch the jockey at the C terminal, you are getting the deflection on the opposite side. Once you are getting this deflection on either side of the 0, that means your connections are correct. If you are not getting the 0, either side 0, then you have to check your connections, whether any wire is loose connection, whether any wrong connections you had done. Okay, so in this case we are getting the deflection on both sides. Now how to take the readings? See, initially for the resistance box, for the resistance 30, we have to find the null point. Okay, for that we have to touch the jockey at the different points on the wire AC. Okay, like this. You can see there is a deflection whenever you are touching the jockey on the wire. See, there is a 25 divisions. Okay, in this way you have to touch the jockey at the different points on the wire, so that you are getting the null deflection, that means the zero deflection, and you have to find that. Okay, so find that null point where you are getting the zero deflection, that means the zero deflection. See now, at this point we are getting the zero deflection in the galvanometer, as you can see here. Now at this point, that means this point is the D point, okay, and it forms the complete Wheatstone's network. How? See, this is the A terminal, it's a B terminal, that one is the C terminal, and this one is the D. That means it forms the quadrilateral ABCD. So it is just like the Wheatstone's network. Okay, so this B point here, whatever we got, that is known as a null point, because at this point we are getting the zero deflection, that means there is no current flowing through the galvanometer. So whatever the length of the wire, this one A to D, this AD length of the wire, whatever that length, that is denoted as a LX. Okay, that is the length for this unknown resistance. So that we can measure with the help of the scale. So as you can see, there is this length is the 42.5. Okay, this length is the 42.5. Now this length, the remaining length will be how much then? Obviously it is a 100 centimeter wire. Okay, so if the Lx is the balancing length for the resistances as a 42.5, so obviously for the resistance box, that length will be the 100 minus 42.5. Okay, so that length will be the 57.5. Okay, so in this way, for the resistance 30, we are getting the balancing length Lx and the Lr, and that we have to write in the observation table. As you can see in the observation table, see, this is the series combination. Okay, so readings we have to write here, the resistance from the resistance box. So here first reading we will write as a 30, because 30 ohm resistance we had taken. Lx whatever 42.5 we will write here. Lr we will write the 57.5, and then we have to do this calculation. See, R value we know, Lx we know, Lr we know. So doing this calculation, you will get the first value of the excess, and we have to repeat the same procedure for the next three resistances. For example, we had taken for the 30 students. Now suppose take the value of the resistance as a 20. Okay, suppose 20. That means 10 you have to insert. So for the 20, again we have to check whether we are getting the deflection in the galvanometer on both sides or not. As in the circuit you can see there is a deflection in the galvanometer on both sides. See, whenever we touch at the C, we are getting the deflection on the other side. Whenever we are touching at the A, we are getting the deflection on the other side, opposite side. That means for the 20 value of the resistance, we can find the balancing length. For that, touch the jockey at the different points on the wire and find out at which point you are getting the balancing length. Okay, in this way you can take the three readings for the different values of the resistances. Okay, and these values we will write here three values for the series combination, three values. Okay, now see the second again we have to take the more three readings. For that, what we have to do, only we have to interchange the position of these resistances and the variable resistance box. We have to interchange the position. That means only you have to remove from here this resistance box and this resistances, okay, like this, and only we have to interchange their position like this. Okay, we have to connect here, and this one we have to connect here. Same way we have to do the connections. That means in the first case, whenever that unknown resistance in the left gap, three readings we had taken. Now we had interchanged the position. That means the unknown resistance in the right gap. Again, three readings we will take. This is for the accurate reading we want. That's why we have to interchange the position. Now in this way, again three readings we will take for the three different values of the resistances by repeating the same procedure. What procedure? Let me repeat. We have to take the some value from the resistance box. Check whether you are getting the deflection on either side of the galvanometer, that zero in the galvanometer. Then touch the jockey at the different points, find out the null point. Once you are getting the null point D, you can measure the length Lx and the Lr. Now in this case, suppose D point you are getting here. Now this length is the Lr now, because resistance box is on this side. Okay, and whenever you are connecting this unknown resistance in the right gap, so whatever the remaining length, that will be obviously Lx. Only this difference you should remember. So in this way we can find the value of the series combination, that is the effective resistance in the series combination, that is the XS in the two times. One is in the right gap and one is the left gap. So 2 XS we will get, add both the XS, you will get the with the average, you can find the average XS1 and the XS2. XS1 plus XS2 divided by 2, that means average you are finding. So the exact value you will get, that is the XS, that means the effective resistance whenever you are doing the series combination. And now in the next video, let's see how to do the parallel combination and how to do the adjustment and how to take the readings. Okay, thank you students. Please welcome my dear students. Now see, it's the third video for the experiment verification of the laws of the resistances using Wheatstone meter bridge. In the previous two videos, we saw how to do the connections. We learn about the circuit diagram. In the second video, we saw how to do the connections for the series combination and how to take the readings. Now in this third video, how to do the connections for the parallel combination of the two resistances, and we will see how to take the readings. Okay. Now see, the remaining connections are similar to the series combination. Only difference is in this part. Okay, that means the parallel combination of the two resistances. X1 and the X2, now we have to connect in the parallel combination. See how to do the connections. See, this is the first resistance X1, whose one terminal, from the one terminal goes to the wire to the one terminal of the second resistance. And also from the second terminal of the first resistance goes to the second terminal of the second resistance. And from both the second resistances, that is connected in the left gap. Okay, so this is the parallel combination. Now in the parallel combination, we kept the two resistances one below the other. See students, in the series combination, we kept the two resistances one after the other. 1-to-1 connection was there. But in the parallel combination, as shown in the circuit diagram, see in the circuit how to do the connection. See here, the common terminal is there, no? So that's why this common terminal is there. And one common terminal we have to connect in the gaps. Okay, see this common terminal. See, these are the common terminal. Okay, so same way we have to do the connections. And now see how to take the readings. First we have to do the adjustment. For that, so we have to take the some value from the resistance. Suppose this 5 ohm resistance we had taken. Okay, from the resistance box we had taken the 5 ohm resistance. Then close the key. Okay, and switch on the circuit. Okay, switch on the power supply. So what we had done, connect the two resistances in the parallel combination, take the some value from the resistance box, close the key and switch on the circuit. Okay, and then touch the jockey at the A terminal so that you should get the deflection, same way in the parallel combination. Now same adjustment we have to do. Whatever we have to touch the jockey at the A terminal, so you will get the deflection A and the C terminal, so you will get the deflections on the either side of the 0 in the galvanometer. Same we have to check. And if you are not getting, as I told, you have to check your connections. Whether any loose connection is there, any wrong connection is there. Okay. Once you get the deflections on the either side of the 0 in the galvanometer, then you have to find the null point. Okay. Similarly, whatever we had done for the series combination, now by touching the jockey at the different points on the wire, we find the null point. Once we get the null point D, we measure the length AD and the DC. Okay. So AD length will be, suppose here we are getting the null point. Then this length will be the AD and that AD length for the unknown resistance. Okay, that means a parallel combination of the resistances, and the remaining length will be obviously for the resistance box. Same way, same procedure you have to repeat for the parallel combination also. Okay, same adjustment we have to do, only the difference in the connections of the two resistances. Okay, so same way we will take the 3 readings for the resistances in the left gap. Okay, and we will repeat the experiment for the interchanging the position of the resistances and the resistance box. We have to connect the resistance box in the left gap, and this same combination we have to connect in the right gap. And similarly, with the same, repeating the same procedure, we have to take the more 3 readings. So you will get the 2 values of the XP, that resultant resistance for the this combination will be XP. P denotes for the parallel. Okay, so you will get the 2 values, because first value you are getting in the left gap, second value you are getting in the right gap. Okay, so XP1 and the XP2 you have to add them, divide by 2, that means you have to find the average of both the values, and then you will get the resultant value of the effective resistance of the parallel combination. Okay, and we have to verify the law means what? See, XP value from where we will get theoretical value we can find, because the values are written on the boxes. See here that value is written 20 ohm. See, you can see there 20 value is written. Okay, 20. So suppose this is X1 and suppose this is X2, that value is the 10 ohm. Okay, 10 ohm. For the series combination directly we can add, that is the 30 ohm resistances. Okay, so theoretical value should match with the practical value. Okay, in the series combination we obtain the excess practically also, and theoretically also we can obtain. Same way for the parallel combination also we can obtain the XP value, that is with the practically, and we can calculate with the theoretical formula also, and we have to verify whether these values match with each other or not. Okay, once they are exactly close, near, then we can say that we have verified the laws. And here we have completed the experiment, verification of the laws of the resistances, that is a parallel combination and the series combination. Thank you, students.